I'm here, right? An iron pillar consists of a cylindrical portion. Okay, let me draw the cylindrical portion over here first, so that yeah, so this is your cylindrical portion, right? Right, of 2.8 meters height. The height of this one is how much? 2.8 meters. Okay, 2.8 meters is the height of this one from here to the other end, right? That's up to only here, right? Okay. Now, in the next sentence, and 20 meters in diameter. So from here to here is how much? It is around 20 centimeters, right? It's not meters, it is centimeters. And a cone of 42 centimeter height is surmounting it, means it has kept above it, something like this. Okay, the height is given as how much? H is equals to 42 centimeters. So let me write this one here. 1 centimeter cube of iron weighs how much? 7.5 grams. So this is clear to everyone, right? So let me write it down over here. So volume of the iron pillar, you need to remove it, right? So first of all, let us of the cone also, right? So let us just see this one, how we will do this. The volume of the cylinder is written by the formula I r square h, right? And similarly, the volume of the cone is written by the formula 1 by 3 I r square h. So this is clear to you, right? So let us substitute the values here. The value of I is 22 by 7 into r square. R square is given over here is your diameter, right? So given over here is diameter equals to 20 centimeters, then the radius is equal to half of your diameter. Now the resultant is how much? If I divide this, the answer is only 10 centimeters. So R is 10 into again 10 over here. Now the value of H, if you look at the value of H value is given as 2.8 meters. Okay. Now every values are in centimeters only. So now we need to shift it to your meters, right? So how do we do that? We can do that simply doing this into 100. Okay. So if I do this into 100, the resultant is how much? 280 centimeters. So this is clear. So the H value is 280 plus 1 by 3 into 22 by 7. Okay, 22 by 7 into R value is the same. So that I write n into n here. And the height of this is what? 42. Oh, this is clear, right? So see this cancels out this one 6 times. So I'm clear, right? 6 into 42, right? Good. Now, eventually this cancels out this one how many times? 40 times. Okay, up to here it's here, right? So let us solve this one here. See, when I'm doing this one into what is the resultant? The resultant of that one is what? 100 into 40 plus, now even this 3 handles this number 2 times, right? So when I'm doing this into, it is 100. So 22 into 100 into what? 2 is left out, right? So let us see this, how we'll do this. Now I'm doing these two into, that is 880 into 100 plus, now doing these two into also, let me do these two into, this is what? 88, I'm sorry, it's not 80, right? It's 44 into 100, isn't it? Now doing this multiplication here, this is your resultant of this one, right? Similarly, if I do this one multiplication, the resultant of this one is what? 4400, right? So when I'm adding up these two, the total volume came out to be 9244 centimeter cube. Oh, this is clear. So this is your volume of the iron pillar, right? Now, as you said earlier, 1 centimeter cube equals to this much weight. So let us look at the weight of the iron pillar. Weight of the iron pillar. What would be the weight of the iron pillar is 92400 into, I need to do 7.5, right? This is your grams. Okay, this is your grams. So when I solve this, the answer is what? 693 grams. Okay. If you're required to shift this in as your edges, I need to divide with what? 1000, right? So that the resultant is 693 edges. Hope this is clear to everyone. You may write this as your answer, or you may also write this one as your answer. Okay, good. Let's look at the next one. Okay, let's read this. A toy is made from circular base is joined with the plane surface of the hemisphere. Okay, the radius of the base of the cone, the radius of the base of the cone is how much? 7 centimeters. Means here R is given as how much? 7 centimeters, and the volume of the hemisphere is given is how much? This much, right? Now he is asking us calculate the height of the cone. He is asking us to remove the height of the cone and the surface area of the toy as well. Okay, so let's see how do we do this one here. First of all, let us remove the height of this one here. Okay, so how do I remove the height of the cone? So let me write it over here. Height of the cone you need to remove, right? So height of the cone is equivalent to, how can I remove this value here, right? That is, a hint is given here, that is volume of the cone is equivalent to 3 by 2 times volume of the hemisphere. Hope this is clear. This information is given here, right? So what will be the volume of this one? This is 1 by 3 pi r square h, okay, is equivalent to 3 by 2 into volume of this hemisphere is 2 by 3 pi r cube. Okay, how do we solve this? This remove this one also answered out simply, right? So let us substitute the values now. See, this pi and this is also removed out. Okay, r value is given as 7 centimeters, isn't it? So here 1 by 3 into 7 into 7 into h is equal to 7 into 7 into and one more 7. Hope this is clear. See, this double 7 and 8 double 7 is removed out directly, right? So now I have left out with h is equal to 7 into 3, that is h is equal to how much? 21 centimeters. Hope this is clear to everyone, right? So the height is obtained as 21 centimeters, right? So this was your first this part. So next he is asking us to remove the surface area of the toy, right? So let us remove the surface area of the toy. That is, I can write surface area. Let me write the surface area. Or else, okay, let me write it above here. Surface area of the toy is equivalent to what? It is your CSA of your cone and added with CSA of the hemisphere, isn't it? CSA of hemisphere. Okay, hope this is clear to everyone, right? So now CSA of the cone is written as pi into r into l plus CSA of the hemisphere is written as 2 pi r square. Okay, so let us substitute the value. He has given us a note. I'm just ignoring the note and just substituting that value here directly. That is 22 by 7 into r value is how much? 7 into l value into mu. L is your slant height, that is l is equal to h plus r square, right? So L is equal to, this is 21 square plus r square is how much? 7 square. Hope this is clear. So now the L value comes out to be root of 441 is 21 square and this is this much, right? If you are adding this to here, what I will be getting? I will be getting something like 9 over here and I will get 4 over there, right? So the root value of this one is approximately 22.135 centimeters. Okay. So let me substitute this 22.5 centimeters. So I'm just substituting that one here as 122.135 centimeters plus 2 into 22 by 7 into r value is how much? 7 into 7. Hope this is clear. And 7 is removed out from here and 1 more 7 is removed out, right? I'm doing these two into, when I do these two into, right? The resultant of this one comes out to be how much? The resultant of this one comes out to be like approximately, if we will do this, we'll get 486.990 plus, now when I do this, this is your 44 into 7. If you do that, we'll get 308, right? So when we are adding this, we'll get in the answer 749.990 centimeter square. Hope this is your required answer, right? Hope this is also clear to everyone. Okay. So let's look at the next one. Now he's asking what he's asking us to remove or find the volume of the largest circular cone that can be at out of a cube whose edge is 7 centimeters. Hope this is clear to everyone, right? You are having a cube of 7 centimeters of a side, right? So this should line. Similarly, this part here, this should be a cube. Decimeter is a cube, it's not a cuboid. Okay. Now out of this, you are having what? A circular cone you are having, right? So you have some circle like this, and you need to remove this area. Okay, he's asking us to remove this area. Okay, right, good. So this is clear to everyone. So let's see how we'll do this. And yes, it's given us how much? 7 centimeter. Okay. Okay, now see, if you were having 7 centimeters, what would be the value of R? R is your diameter of this 2. R is diameter is how much? 7 by 2. Now R is equal to 3.5 centimeters. If you would see in the diagram, this edge is touching up to this edge, isn't it? That's the reason, right? Now, what is the height that we obtain? It is roughly 7 centimeters. If you look at the diagram, it is touching this area, right? Okay, good. So you are having here a D and you are also having a H. Hope this is clear to everyone. Okay. So what would be the volume you can remove? So volume of the cone which can be removed out of this diagram is volume of the cone is equal to what is the volume of the cone? V is equal to 1 by 3 pi R square H, right? So 1 by 3 is as it is, and the pi value is 22 by 7 R square. R value is taken as 3.5 into 3.5, right? Into H value is taken as how much? 7. Hope this is clear, and this one is removed directly, right? Now we are left out with this thing. How do we solve this? By solving this, you should be getting the answer. So if you solve this one out, right, you will be getting how much? 89.83 centimeter cube. So this is your answer part here, right? So what happens if this divides if this divides out approximately? So when I divide this one with the table, right, I will have to what 4.08 or something, right? So when you're doing this two into what would be the resultant? The resultant would be quite simple. That is the answer. When I do this one into we are left with what 89.8 as your answer, and rounding this one off is 89.83 centimeter cube. So this is clear, right? Let's look at the next one here. So what should be done here? Let's see. A cylindrical tube of radius. Okay, we are having a cylindrical tube. Okay, let me draw the cylinder first. Okay, this is your cylinder, require a cylinder of radius. It says that R equals to how much? 5 centimeters. Okay, and length is how much? 9.8 centimeters as your height. Okay, as your height. So this is clear, right? A solid in the form of a right circular cone mounted on the hemisphere is immersed into the cube. Radius of hemisphere. Okay, now let's see this part here. A hemisphere, you are having a hemisphere which is surrounded on a cone. Okay. Now he says that the radius of this one is how much? The R of this one is 3.5 centimeters, and the height of this cone outside the hemisphere is how much? Now he's saying about you this hemisphere. So this is clear. Now find the water left in the tube. Now assume that this cylindrical has some volume of water in it. Okay. Now you are using this and you are inserting into this one and you are removing out some water. Okay. After removing it out, the level of this decreases, isn't it? Now he is asking us this decreased volume is that how much? Hope it is clear to you, right? So let us solve this one here. The first thing is the volume of water left in the tube. How do I remove that? See, volume of water left, you need to remove volume of water left. H2O is your chemical form of water. Volume left is equals to what is that? The volume of water is available in which one? In the cylindrical tube, right? Which is what you are removing it out minus I need to remove with the volume of this solid, right? So let us substitute everything in a single space and so that we can solve it easily. So the volume of the tube is how much? It is your cylinder IR square H. Now volume of this solid. What would be the volume of the solid? It is your volume of cone plus volume of hemisphere. You need to add up these two. Okay, so that would give us pi r square h minus volume of these two. Volume of the cone is nothing but 1 by 3 pi r square h plus volume of the hemisphere. Volume of the hemisphere is nothing but 2 by 3 pi r cube. Hope it is clear, right? So now substituting everything, okay, I'm taking the value of pi here. R value of the tube is how much? 5 into 5 and H is given as 9.8. Hope this is clear, right? So minus next one. 1 by 3 into 22 by 7 into R value of the cone is given as 3.5 into 3.5. H value is how much? Into 5 plus. The next thing is 2 by 3 into 22 by 7 into R value is taken as directly, that is 3.5 cube. 3.5 cube. Okay. So let's just solve this easily so that we can get the answer done out, right? So what we'll do is just bring everything multiplication here. So what do we get if we do everything multiplication over here? The result is 5390 divided by 7, right? Minus. Now doing above everything above multiplication over there so that I can sort this one out. This comes out 0.5 times here, isn't it? And similarly, now when I do the numerator multiplication, I have left with what? 22 into 12.25 by 3 as your this part, right? Plus, similarly, if you are looking at this part, if you are doing the multiplication over here, it will be left out with what? 192.5 by 3. So this is clear to everyone because you can remove this one here, do the simplification yourself. If you have any doubts, you can ask me on my WhatsApp number or in the group. We are having so many special media links, right? We can ask your doubts over there. So let's see how do we do this part here easily. Okay, so that the volume of this one. So is it divisible? Yes, it is divisible. If you are able to divide this is comes out to be 770. Okay, minus do this into and divide it, then you will be left out with what? You will be left out directly with 269.5 by 3 plus. If I solve this one now, this comes out what? 192.5 by yeah, this is left out as right by 3. Hope this is clear to everyone, right? So this is clear, right? See, what I have done here is quite simple. This multiplication, whatever I have done here, okay, this multiplication is the volume of the hemisphere. Okay, get it cleared. Okay, this is your volume of the hemisphere. That is this area. Okay, and this I have done it here. Okay, and this is repeated here. Okay, right? There's no dilemma in this. Okay, good. So let's look at the next one here. When I solve this, this comes out 770 minus. So if you solve the bracket one, this comes out to be 154. Now if you subtract this, this is 116 centimeter cube. Yeah, I have now done the multiplication because there is lack of area to do that. Okay, so let's go to the next one. Okay, if you have two equal holes of radii, okay, and height, okay, this also given over here, right? Right, good. As I talked, as shown in the figure, now he is asking you to find the remaining volume of this solid. Now, volume of the solid left out, volume of the solid left out is equivalent to volume of the solid minus 2 into volume of what? The ounce. Hope it is clear to everyone, right? So let's see how do we do this. What is the volume of this solid? The volume of the solid is your volume of this cylinder, isn't it? So the volume of the cylinder is written as pi r square h. Okay, this is your what cylinder. Okay, minus 2 into volume of the cone is 1 by 3 pi r square h. Hope it is clear to you, right? So let's see in the next step the volume of the cylinder, that is 22 by 7. The radius is half of your diameter. Okay, see the diameter is given as d is equals to 7 centimeters and r is equals to your d by 2. So that this reduces out to 3.5 by 2. That is, I'm sorry, so this is the 7. Then r comes out to be what? 3.5 as your answer, right? And the height is given as how much? 10 centimeters minus 2 into 1 by 3 into 2 by 7 into r value is 3 and h value is how much? 4. Right? It's clear. So and 3 and the other 3 is removed out and this cancels out like 0.5 times here. So if you do these two into you are having what? 50. So 22 into 3.5 into 50 minus 2 into doing these two into is how much? 22 into 12. Okay, now doing these two multiplication and again these two multiplication, right? So that I have lot of with watts. Now over there 1.10 into 3.5 minus doing those two 22 into 24. Hope this is clear. Hope this is clear, right? So I hope this is clear. Now let us do this in an easy way. See, when you're doing this two multiplication, right, you're using the 11 table, I can write this directly as like this, minus 22 into 24, you need to solve that 22 into your 24. If you do this, 22 into 24 comes out approximately, you'll be getting 528. So this is your 528 is your answer over here, right? So now subtracting these two directly, you need to subtract these two directly. Did we miss out anything? 0.5. Yeah, over here I think we got this wrong, right? Yeah, if you're doing this one into you are left with only with the answers. Are you over there? If I do this two into this is removed out, so one more zero is also out of this, right? So then what would we get? Then what would we get is we get 385 minus this part and 7. So I forgot to take the 7. So this is your 7 here and divided by 7. So I need to take this 7, right? So what happens when I divide this one with 7? Out of, so let me write it here. 385 minus 7 goes out. I can't go get your food. Okay, that's it, right? Only one decimal is enough, we can manage with that. So when I do this subtraction here, right, the resultant is 309.6, isn't it? 6 centimeter cube. Hope this is also clear to you. Okay, good. So this is the required answer. So let's do the next one. Okay, so let's look at the next one here. Okay, let's look at the next one here. Spherical marbles of diameter. Okay, you are having some spherical marbles. The diameter is of 4 centimeter are dropped into a cylindrical beaker of diameter. Let me draw a cylinder first of all, which is having some diameter. The diameter of the cylinder is almost 7 centimeters. So this is everywhere, right? It is having some water. Okay. Find the number of marbles that should be dropped into the beaker so that the water level rises. Okay, you are having some level of water here. You need to throw some marbles into this. So whenever the marbles are getting inside this, the volume rises. Okay. Now it says that the volume rise should be how much? Only this much. Hope this is clear. Okay. Now he's asking us the number of marbles is equivalent to how much. Okay. So let's see how can I do this sum here. Okay. Now What needs to be assumed here is, first of all, the radius of this cylinder, let me remove it. R is equal to by 2, R equals to D by 2, R equals to how much? 3.5 centimeters. So this is clear, right? Now, this is your D equals to given as 1.4. The radius of this one is how much? That is your D by 2. So if I do that, the answer is 0.7. Hope this is also clear to everyone, right? So the required thing here is, what it is here is the volume rise you need to remove. Volume rise is equivalent to your total marbles. Okay, total volume of the marbles. Okay, total volume of marbles. That is what. Okay, the next step, what can we when we assume here? Let the number of marbles equals to n. Okay, so volume rise. Okay, let's see that the volume rise. That is, I can say that n marbles required. So into volume of each marble is equals to volume of rising, right? Equals to what? Volume of rising. Hope this is clear, right? Now he says that the water rising is how much? This much, right? And taking this as your H value. Hope this is clear, right? Right? So let us solve this one here. So let the volume of water rise. So that is rise watering is your water rise, right? So volume of the volume of rise in water is equal to your volume of the cylinder only, that is IR square H. Okay. Now similarly, volume of each marble dropped, that is N into, what can I write the marble volume of the marble? 4 by 3 IR cube. So this is clear. Now substituting everything, 4 by 3, I value is taken as 22 by 7 only. They haven't mentioned anything. R value of the marble is what? 0.7 into 0.7 into 0.7. Okay. Is equivalent to how much? Is equal to this value, that is 22 by 7 into R square of this one is 3.5 into 3.5. Like into H value, we assume it has to be 5.6. Or is it required, right? Similarly, this one and this one is removed completely without any doubt, isn't it? Isn't it without any doubt? They have been removed out. And let's see what can be done. Now shifting this one to the other side, that is L is equal to the required number of marbles is doing this 3 into here. When I do this 3 into, right, what I will get here is, if you do that into, we'll be getting 68 pointers. So that is 22 into what? 68.6. Right? I'm shifting everything to the other side here. Okay. 7 cube is how much? 7 cube is, can be written as, isn't it written as a 343, as you're having 3. Yeah, the what would be the volume of 7 cube is 7 cube is written as 343, right? As you're having 3 different decimals here, 1, 2, 3, so the result of this one is 0.73. So this is 4. I can write here into 3. This is what? 0.343. So this is clear, right? Now doing this is into, if you're doing that, we're doing that one as into with the, if you get the denominator, right? So very good. That denominator, if you do this into, this comes out 1.372. Okay, and similarly, if you do the numerator into, you need to do everything into, so that you can do it here, right? So we are having it 4572.6. Right now, if you divide, you should be knowing the division recipe. Okay, then only you will be able to sort this one out. Wait, did we do anything wrong? Actually, we are not having 22 over there, right? Why do we write 22 here? Okay, you're not having 22. Ignore 22. You should not try this one. So this answer again changes. So you need to do what is 68 into 68.6 into 3. The answer comes out to be 205.8. Right now, if you divide these two, now on dividing these two, what would be the resultant? You need to do it properly. Okay, if you do this properly, right, and get n is equal to 100. So the required number of marbles are how many? Marbles required to rise. whereas 5.6 centimeters are 150. Hope this is clear to you, right? 50. Okay. Right. Hope this is clear. Let's look at the example. I think this is your last part. Yeah. So let us look at meters, right? So the radius of each depression is how much? 0.5 centimeters. And the depth is also given. The depth is nothing but your the required height. Height is how much over here now? 1.4 centimeters. So this is clear. Now it's asking us to remove the volume of the wood in the entire hand here. Okay. So how do we solve such some series? It's simple. That is volume of the wood you need to remove it. So volume of the wood we need to remove is nothing but as I said that volume of cuboid minus 3 into volume of each depression. Right? As we're having 3 minus 3 into volume of each depression. As you're having 3 depressions, I'm using 3, right? So 3 into volume of each depression. So volume of each depression is written over here, right? So let's always the volume of the cuboid. So what would be the volume of the cuboid is L into B into H is the volume of this one here minus 3 into volume of each depression. Each depression is the volume of your what stone. Each depression is in the shape of your stone, isn't it? So it is 1 by 3 into IR. So here the volume of the values which is taken as 1.4. If you look at this one and this one directly 2.2 times. Now when I do this one into over here, I have left with 15 into your 35, right? So let me write it properly. 15 into 35. This can also be written as 1 by 2. So this is the resultant, and this is 11, right? So if you are doing 15 into 35, what would be the resultant? If you do that the multiplication of your first copies, this would be 525 minus this is nothing but 11. Okay, this is nothing but 11. So the answer of this one is 500, and what out this comes out to be 113 roughly as your answer. So this is clear. 3.5 into your answer. We are over here. I think yeah, this if you're doing into this is 0.1, right? So if it is 0.1 over there, then we would get this as 1.1 only. Now, if I solve this comes out minus there will be having what? There will be having 3, 2, and 5. This